Hey guys, welcome back to the channel. I have another ECM test, this time in a marine ECM from Chinn. I have a paper of him in here. Let me just cover a little bit of his information so he will see that that is his. So it's a 2006 Malibu um, 8.1 Indmar, only for 2 years. He said that first it will die and then not restart, no fuel pump. And dash reads engine ECU, no data. So yep, I connected the computer to Diacom. Let me just do it again for the video. So the first thing, well, right now it's on. The first thing that I noticed, no fuel pump activation, which will be right there. No main power relay, no fuel pump activation. We got a little bit of a draw, let's say 150 milliamps. Not enough for this one to actually be completed on. Um, Let me try to establish communication. So again, this is Marine Diacom, and this is MEFI 1 to 4, and that will include obviously the Indmar. So I'm just going to let this run for the video again, testing on his computer. I know for sure it's not going to communicate. Yeah, as you see, no communication. All right, so the first thing that I wanted to do on this one, as you see, I have again gather all those information or this information to test these computers. And the first thing that I wanted to check is the voltage regulating area right here. So we got the voltage regulator for this computer, and most important, and then the 5-volt reference. But yeah, so I have my multimeter connected to ground through my simulator, and then just using the other test lead in here. So we're going to check this point, 12 volts, and then the 6 volts, which is right here, right? So let me get this in the same area so we can all see this. And so it will be him. All right, so this should have 12, around 12.4 based on my current voltage, and that is good. Um, the upper one right there, that should read 6.3. So trying to get you guys the best close possible. We got already 1 volt drop. That's no good. This one should read battery voltage, and it is good. And the reason this is low and it's no good, this goes through the voltage regulator. Okay, so let's take a look more around the area. Well, let's take a look at this other 13 voltage, 13 volts right here, and then we'll start to look into this 5 volts and 3.3 area, which is at the end the most important one. So we should have 13 volts in here, and sorry, we do. I'm going to check the upper one. So again, we are in this area, 5 volts, 3 volts, right? So this one right here should read 5 volts, and we got only 4 volts, no good. 3.3, we got 2.7 volts. This is not looking good. Um, this upper one should read 13 volts, and the 13 volts is there, so we got the supply voltage that this computer needs to have. And some of the 5-volt reference are there, actually none, because this is the one that reads like 5.2. It should be read at 5.1. It should be read 6.3. You see that right there? So yeah. Let's take a look at this other one on the bottom, because these 12 volts goes through this resistor and then produces these 5 volts in conjunction with the voltage regulator. This is the voltage regulator right here. So again, we are here. Let's take a look at the battery voltage. And we do, it's not really full battery voltage, but it's 12.5. And if we read right there, that is right in the morning, 12.5 volts. You see that right there? So take a look at this. This should be okay if we have this in, unless the resistor is no good. So we got that 5.277. I might have rounded up because I put 5.3, 5.277. That's close enough for me. So let's take a look at these other 5 volts in here. This one is dead. Yep. So we are now checking these 5 volt reference in here and these two. So right here, that one next to the one we just read again through the resistor. And then we're going to check this one and this one. They should both read 5 volts. Making sure I am doing good contact, and we can see right here that this reads immediately. So we got a dead voltage regulator, and this one is on 4 volts. The reason we are low is because this voltage regulator is not supplying one of the 5 volt rails. Um, yeah, that's it. This, I mean, I can keep poking around and do more, but realistically, with the experience I have and everything, I know as a fact these will prevent the computer to come up because it will not be providing the complete 5 volts which is necessary for this microprocessor to produce the SPI communication for the EEPROM, which is right here, and then at the end read the information, calibrations, and everything, and then make the engine work, right? So we have in this microprocessor we got 2 voltage rails. Let me show you that. So we can go away from there. So we got a 5 volt. Let me point with something in here. So we got the 5 volt reference in here, and then at 3.3 in the center, it's just a ground path. So again, this outside one should read 5 volts and 4 volts. The inside one should read 3.3, and we got 2.6. That's no good. And that's why this computer is not coming alive. And the reason he might have it sometimes and work and then dies is because again the voltage regulator is dying. So when this one dies, it takes the communication off because then the signals that are being pulled down and producing the communication cannot be established. Remember, the clock on the computer and on the EEPROM, right, has to reach and pass certain thresholds. So if we have already the supply voltage low, it will not be able to pull up or pull down. I mean, it depends on how the signal works, and then complete the communication. And that's not only that. I mean, we will have then low 5 volt reference on the sensors, and then we can see that as well here. Let me unplug the multimeter because I have done on the wiring. I have the wiring that I connect always to the computer. I have the sensor ground in here and the 5 volt reference. So let's see what we have here. 4 volts. So yes, yeah, we already got a problem, right? So we got 4 volts. We got a missing rail inside the computer that will produce auto rails for the rest of the computer to work. So Chris, I am sorry, but these are things I cannot repair on these computers. Um, these computers has many components that I can repair. I can reestablish pads when a pad is missing. Again, that is or broken, let's say not missing. I can fix that. I can replace all the majority of these surface mount components, which I have, and you can also check all my MEFI 3, MEFI 4 series of videos that I have in the channel. But when it comes to crystal, that's it. So we have the 5 volt, or the 5 volt regulator. We have this auto crystal, obviously the microprocessor. This is for IAC, if I am correct. And then we have, like you see, multiple crystal components. These are MOSFETs, and here there are crystal. These are for the, let me just make sure I'm saying this right now. This is for the coil and EST signals, and I will have to see again the values for these ones or the actual component location for these ones. Those I cannot repair. I cannot replace. That will be the end of the line of the life for the component for the computer. And it's a shame because looking at other modules that I have been able to repair, most of them, the jumpers are cooked. These ground pads in here, so these lines in here, these two brown lines in here are the main ground pads. And I mean, like, there is always, especially on these type of boats, you know, corroded grounds and etc. And that's where you will first see the problem because it's um, a lot of amperage when when you're starting a boat. That will take any ground possible to make that boat run, including the ECM grounds. So if the uh, grounds are corroded, it will try to go through here and then end up cooking or the coloring and sometimes damaging the computer as well. And this is also what it damages the computers at the end, corroded grounds that changes the voltage so low. In this case, so for Chris, I will probably suspect more shorted to power on the 5-volt reference than anything else. This circuit, sensor grounds, and so on, is meant to be pulled down. Even again, not forever, right? So if you have a short to ground, it can end up damaging the 5-volt regulator, but that is a most common use of because the regulator knows that sometimes it's going to be pulled down to ground. So the majority of the signals, including the sensor ground, which is not made to carry a lot of amperage, is meant to be pulled down. But pull up, no, it's pull up to 5 volts. But then when you short the 5-volt reference to power, none of those capacitors, none of those protections are meant to be protected that way. And that's when, boom, the 5-volt reference or 5-volt regulator start to get damaged because now you're shorting it to 12 volts and 12 volts and 12 volts. If it's a constant short to power, it takes the 5-volt regulator. All right, guys, this is as much as I will do for Chris. This is just so he can see that this is his computer, and that's all the numbers. As you can see, it's an Indmar ECM MEFI 4, and that's the end of the road for this one. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe, and as we say in Costa Rica, pura vida. See you next time. Bye bye.